Hello class. Today we're going to be going over domains of rational functions. And if you recall what a domain is, we've talked about it a few times so far this year. A domain is all the possible x values a function can have. So moving from left to right, what values does the function exist at? And when we're talking about rational functions, the domain of rational functions will exist everywhere except at the vertical asymptotes. So we have two ways of doing this. One, we can determine the vertical asymptotes algebraically, or we can graph it. And I'm going to show you both today. So let's go ahead and find the domains of these four functions. So first, we have 3x squared minus 6x plus 9 divided by x squared minus 9. So let's go ahead and find the vertical asymptotes first. So recall, to find the vertical asymptotes, we're just concerned with the denominator, and what we want to do is, well, the asymptote happens when the denominator equals 0. So to figure out what value we can plug in where it'll equal 0, we want to set it equal to 0 and then solve for x. So I can take x squared minus 9 and solve for x. So I set it equal to 0. Let's see, we can add 9 to both sides. X squared equals 9. And then remember what undoes a square? Square root. So x is going to be equal to positive or negative 3. Well, positive and negative 3. So this is where the function doesn't exist, at x equals negative 3 and at x equals positive 3. And I went ahead and I graphed this for us. And there you have the graph of this function. Notice at x equals 3, which is right along here, and x equals negative 3 right along here, it's asymptotic. It doesn't exist there. There's kind of like a gap going on. So we can say that this function exists from negative infinity all the way to negative 3, and it doesn't exist at negative 3. But then it exists in this little section in the middle from negative 3 to positive 3. And then it doesn't exist at positive 3. And then going to the right from 3 towards positive infinity, this thing will exist. So how do we write that? Well, when we are talking about gaps in a domain, we're going to be using unions. So unions just kind of connect two sections of domains, but it omits what's in the middle there. So we discussed this one goes from negative infinity to negative 3, and then parenthesis. Remember, we use parentheses when it doesn't exist exactly at that point, so make sure to use parentheses instead of brackets. And then union, it's kind of like a U, and then it exists from negative 3 to positive 3, and then another union, and then it exists at 3 towards infinity. So we always go from left to right when talking about domain. So it exists in this section. It doesn't exist here. It exists in this section. Doesn't exist here, and then it exists in this section. So let's now talk about this one, x minus 4 over x squared plus 5x plus 4. So again, let's identify what our vertical asymptotes are. So in this case, this looks like a factorable equation, or if you like using quadratic formula, you can use that. So let's take a look at this. We're going to have x squared plus 5x plus 4. So to factor these kinds of equations, we want to find two numbers that add to the middle number, 5, but when we multiply them, we get 4. So what two numbers are those? And what comes to mind for me is 4 and 1. 4 plus 1 is 5. 4 times 1 is 4. So we're going to write this in factored form now. X plus 4 and x plus 1. Now, to find the zeros, we set each factor equal to 0 and solve for x, just like what we did up here. So x plus 4 equals 0, and x plus 1 equals 0. And if we're to do the math, we're going to get x equals negative 4 and x equals negative 1. So those are our two asymptotes, at negative 1 and negative 4. So I went ahead and I graphed this one for us. And this function looks like this. Notice at negative 1, it doesn't exist. All right, let me, it's a little nicer, there we go. At negative 1, this function doesn't exist. And at negative 4, this function doesn't exist. It's asymptotic at those points. So, just like we did this one, this function is going to exist from negative infinity to negative 4. And then union, it doesn't exist at negative 4, but it exists from negative 4, or infinitely close to negative 4, to negative 1, but it doesn't exist at negative 1, union. And then it goes from negative 1 to positive infinity, just like that. And we can verify that by looking at the graph here. So it doesn't exist in this on these 2 points, but it exists in the middle there. That's from that negative 4 to negative 1. And it exists from negative infinity. This exists all the way over there to negative 4. And then this right side exists from negative 1 all the way to positive infinity. So that's some neat stuff. Let's take a look at this one. So here we're going to set our denominator equal to 0, solve for x. We don't need to factor in this case. X minus 4 equals 0. Do the math. We're going to get x equals positive 4. So this only has one vertical asymptote. So I graphed this one. And I got this function. And notice at 4, let's see, notice at 4, it doesn't exist at x equals 4. So, but it exists all the way to the left and it exists all the way to the right of it. It's just that one little gap. So, to write that, we're going to write it exists from negative infinity to 4, union 4 to infinity. So this is saying that it exists all the way to the left up until 4, but not at 4. And then it exists at, well, not at 4, but it exists after 4, and then all the way to infinity. So one more. Now we have x squared plus x minus 5 over x squared. We're going to set the denominator equal to 0. And solve for x, right? We take the square root. This is an easy one. Take the square root of both sides. X is just going to be positive or negative 0 or just 0. So, let's see what the graph looks like. See if we can confirm it. And there we have it. We have a rational function, a graph of a rational function, where it doesn't exist at 0. Notice that it kind of yeets away from it, right? It gets infinitely close to 0, but never touches it. So, how do we write that one? Well, the domain exists from negative infinity to 0, union, because it doesn't exist at 0, 0 to positive infinity, just like that. And that's all I have for y'all today. Have a good day.